Hi, my name is Sadira, and for our Math and Innovations project, we chose to use the Intimidator at Carowinds, and it has a height of 232 feet, a drop of 211 feet, and it is a length of about 5,316 feet. And we chose to use calculus by using the centrifugal force as the cart goes around a loop. And we chose the formula F is equal to mv squared over r, with it being a velocity of 80 miles per hour, a radius of 39 feet, and a mass of 2,300 pounds.
My name is Kareem McLaughlin, and I'll be doing the math behind this centrifugal force here. So first, we have our m, which would be our mass, the velocity v, which we have here, and then our radius r. So plugging it in, we would get 2,300 times our velocity, which is 80 miles per hour squared, over our radius 39. Now we can apply a basic math knowledge, and then we can do PEMDAS first, so we can square this 80, and we'll get 6,400 being multiplied by 2,300 over our 39. And then next comes multiplication. And then once we multiply 2,300 by 6,400, we get 14,720,000 over our 39. And then once we divide this top number by radius, we get roughly about 377,464. Now the units for centrifugal force would be newtons. So what this will end up being actually is F is approximately this number, 377,464 newtons. And that is how calculus is related to the Intimidator.
Hello everyone, I'm Abby,
I'm Cheyenne.
and today we will discuss the connection between math and drones.
And is there one? Many things around us, if not almost everything, has a mathematical connection, like building houses or the workings of a car, or even the drones that record the footage at a football game.
After the first plane, an unmanned aircraft with remote control technology was introduced in 1916 and was known as the Ruston Proctor Aerial Target.
Since then, technology has very much advanced to the things we even consider normal today. So now we can look at a real-life example in a math problem.
Let's look at the graph.
The graph demonstrates the flight path of a drone at a football game over the course of a standard quarter. So now let's look at the question. Based on the graph, what is the speed of the drone from 5 minutes to 10 minutes per yard? So how do we find speed?
Speed is distance over time.
So we have the time. What else do we need?
We need the coordinating y values, which are the distance values.
So what are the distance values?
They are 550 and 10,200.
Okay, so we write that out. 550 and 10,200. So what do we do with these values?
Changing y over changing x.
Exactly. So we use those coordinates, which are 550 over and 10,200. And so how do we set this up?
With the formula delta y over delta x.
Okay, and what's at the top?
200 minus 50 over 10 minus 5, which equals 150 over 5, which then equals 30.
But the units would be yards per minute. All right, now let's move on to part B. Approximately What is the instantaneous rate of change at 7 minutes? Now, what is instantaneous rate of change?
Instantaneous rate of change is change at 1 instant moment.
So what do we need to solve this problem?
Well, we have the time, so we need the coordinating distance value, which is 150.
So how do we set this up?
150 divided by 7.
Okay.
Using a calculator, that is 21.43.
And we got to remember to put yards per minute. And that is how you solve this problem.
Thanks.
Hey, what are you doing?
My silly math homework that I'm never going to use when I'm done with this class.
Of course you will use math in the real world.
Doing what? Counting change?
Of course, math is used in a bunch of things like grocery stores or even airplanes.
Most people think they'll never use math outside of school, but it is used for all the innovations we use every day. Some things are simple, like shopping carts. Others are more complicated, like cars and factory machinery.
But even complicated interfaces use simple math that we all know and learned at school. For example, planes have lots of complicated math and physics problems related to their creation, but we can also use easy math for some calculations.
The Wright brothers plane, the Wright Flyer 3, flew 24.5 miles for 39 minutes. Using a math equation, like the speed formula, we can calculate the approximate miles per hour the plane flew. To do that, we use our given data, which is 24.5 miles and 39 minutes, and we plug it into the formula. Before we do that, we have to convert minutes to hours, which gives us 0.65, and then we can set up our equation. Doing that gives us 38 miles per hour. The Wright brothers calculated the distance, time, and speed the plane would approximately travel. We can calculate how accurate their theoretical data was compared to their actual test. To do that, we'll use the distance actually traveled and divide it by the expected distance. So the distance we actually traveled is 24.5 miles. Divide that by 25 to get a decimal. And to convert it to a percentage, we'll multiply it by 100. So your actual accuracy is 98.
Now you see why we need to use math in our everyday lives.
Yeah, you're right. It was interesting, and now I can see how the math we do in class is related to innovations.